In this video I'm going to show you how to do AQA A-Level Maths June 2018 Paper 2 Question 7. My name is Sunil Tanna. I'm a tutor and author. I live in Buckinghamshire, England. I'm available for one-to-one tuition both online and in person. Function f has a domain of all the real numbers and a range where y is a real number and y is greater than or equal to e. The graph of y equals f of x is shown. The gradient of the curve at the point xy is given by dy dx is equal to brackets x minus 1 times e to the x. Find an expression for f of x and fully justify your answer. So the first thing you should notice is that there is a minimum here on the right hand side. And since it's the lowest point on the curve, it will have the lowest value of the range. So although we don't know the x-coordinate, it's something across. We can see that since y is bigger than or equal to e, this will be something across and e up. The second thing that we'll notice is we're given an expression for dy dx, the derivative, and we want to find the function for its integral to get to f of x. So what we need to do is integrate this expression. And if you look at the expression, it's two expressions multiplied together. And when you have this kind of expression, you want to integrate it, you should be thinking about using integration by parts. And I'll just write on the side here the integration by parts formula. The integral of uv dash is uv minus the integral of v u dash. Some people prefer to use dv and du, so you could also write this as the integral of u dv is uv minus the integral of v du. I'll use the first one in my work calculation here. Okay, so let's use this information that we've got about the minimum first of all. So at the minimum, dy dx is equal to 0. It's a stationary point. So we can substitute that in and we'll have 0 is equal to x minus 1 times e to the x. And e to the x can never be 0, so x minus 1 must equal 0. So this tells us x is equal to 1. And we already know y is equal to e. So we have this coordinate 1 across and e up. So next we can look at finding f of x. So f of x, we know, is the integral of x minus 1 times e to the x dx. So our u is going to be x minus 1, which our u dash, its derivative is 1. Our v dash is e to the x, and if we integrate that, we get e to the x. So using the integration by parts formula, we're going to have uv, which will be x minus 1 times e to the x, minus the integral of v u dash, so e to the x times 1, so minus the integral of e to the x dx, which is going to be x minus 1 times e to the x minus e to the x plus c, because it's an indefinite integral. We now have to find the c. Now we know the coordinate of the minimum. We know f of 1 is equal to e. So we can say f of 1 is equal to e, and that's also equal to, if we substitute that into our expression for f of x, we will have 1 minus 1 e to the x, so e to the 1, which is just e, minus e to the 1, which again is just e, plus c. And that then becomes e is equal to minus e plus c, which tells us c is equal to 2e. And now we can put it all together. F of x is equal to x minus 1 times e to the x minus e to the x plus c, and we've already figured out that c is the same as 2e. If we want to, we could slightly tidy that up. We could expand out this brackets, which will give us x times e to the x minus e to the x minus another e to the x plus 2e. And you can see that there's three items with e to the x in. The last two can be defined as 2e to the x, and then we can have a common factor of e to the x. So e to the x times x minus 2 plus 2e, and that's our final answer.